Okay, I'm going to make this as quick as possible because this is one of the things that students actually struggle with, but it's actually really, really easy. And I'm going to use these notes to actually guide. And I'll explain what plus minus means afterwards. So we have the square root of x plus 3 is equal to 19. Now, remember, from the previous videos, we know that in order to get x on its own, let's get rid of the constants, which is the plus 3 in this case. If we take plus 3 over, it will become negative 3 or minus 3 because the sign changes when you take it over. Now we have the square root of x alone because you took the plus 3 over. This is known as 19 minus 3. 19 minus 3 is just equal to 16. And we're still left with square root of x. Now, in order to get rid of the square root, we know that the square root, there is a 2 here, right? The square root meaning 2. The second root of x is equal to 16. Now, in order to get rid of the square root, if I had a square root, let's say I had a square root. In order to get rid of the square root, I will raise this entire root to the power of 2. That will basically allow me to cancel these out. That's what you must just know. And now, next thing, it's from exponent laws, by the way. You need to know from exponent laws. Now, next thing, if I have, let's say, the cube root, right? In order to get rid of that cube root, I just have to raise this whole thing by 3, so that these can cancel out. Let's say I have the 69th root. If I can just hold it correctly, let's say I have the 69th root. I will basically just raise this by the power of, you guessed it, 69. Therefore, I can cancel these out. Do you understand? Now, that is a law that you need to know when you're solving for x. Now, what do? I have the square root. So basically, I just have to raise this to the power of 2. Now, first of all, in solving for x, whatever you do to the one side, you have to do to the other side. So you can't just raise this side to the power of 2. You have to raise this side to the power of 2 as well. So you can't just raise one of them to the power of 2, you also have to do it to the other side. Now, clearly, this 2 can cancel out now, therefore you are left with x alone, because you got rid of the root now, you got rid of the square root, and we can do the other example and you'll understand. Now, we have the 16 to the power of 2. 16 to the power of 2, you can literally just put that in your calculator. I am not doing it right now. It's a big number, but that's how you solve for x for this instance. Now, also I just realized this is not important for now. It's important for the other one that I'm going to show for the next video. We have the cube root of x minus 1 is equal to 26. Now, remember what I said? We want to get x on its own. Let's take the minus 1 over. Minus 1 will then become plus 1. Therefore, this will be written as 26 plus 1 is equal to the cube root of x. 26 plus 1 is just equal to 27. And then we have the cube root of x. Now remember what I said, whenever you have a root with a number, this is a cube root, you basically have to raise this to the power of 3. You just need to raise this entire root with the number that's already in the root. So, what do I mean by that? Put brackets around this entire thing, and that's why I said get x on its own, like this. You can raise this to the power of 3, so that these two can cancel out. But remember what I said? What you do on the one side, you do on the other side. So you also have to raise this side by 3. And then obviously, because you canceled these out, you got rid of the root, and you have x on its own now. It's equal to 27 to the power of 3, which is also a big number. I don't know why I did this. But anyway, this is how you get rid of roots when you're solving for x. Easy enough.